Okay, we're going to look at the hypothesis from core work 6.2.2. First question says, does the equal values method work for solving systems even when they are not in slope-intercept form? This is a familiar question. Basically, we can look back and we're like, well, yeah, we were able to use the equal values method, but first we had to convert both equations into slope-intercept. So we could say, yes, but only after converting both equations to slope-intercept. It's also worth saying that it's not necessarily slope-intercept, but we'd say or one variable is isolated in both equations. So like we can get t alone, or we can get r alone, or whatever. We have to get the same variable isolated in both equations. And usually that would be considered slope-intercept form. Okay, B, can you think of a way to solve the problem from methods in learning that might be easier than the equal values method? I can, because we've seen this before. We've seen when y is equal to something, then you can take that value and replace it in another location. We've seen that before in some of our preview work. That's called the substitution method. And it seems like that would work better, because then you'd really just end up with 5 times negative x minus 7 plus 3x equals negative 13, which would give us an equation where we could solve for x. So, yes. Another way of realizing this, it's always wise to look ahead. It says a new method called the substitution method. So it's sort of a preview. Yes, the substitution method would probably give us an easier way of solving. That should be no surprise at all. That's the whole point of the substitution method. It works more efficiently than the equal values method in a lot of cases, especially when you have one equation in slope-intercept and one equation in standard.